Hey, eighth graders, I hope everyone is doing well. This week we are we're starting graphing, and this lesson covers a lot and it's very important. So I kind of recommend, well, I do recommend that you guys go through this video and the practice problems at least twice because I give you a lot of information. And once you hear it only one time, you're not probably going to retain all the stuff I'm about to tell you. So like I said, I would probably go through this lesson more than one time. All right, so basically when we have an equation where our x and y variables are to the exponent of 1, for example, if I have an equation y equals 2x plus 3, well, notice I have two variables, an x and a y. They're both to the power of 1. If I don't see an exponent, it's raised to the power of 1, okay? As long as you don't have an exponent greater than 1, it's going to make a linear equation, or it is a linear equation. So do you see the word line in linear equation? That means when you graph a linear equation, your graph is going to be a straight line. Now there's 4 types of straight lines we can get. Our line can either go up and to the right. So even though you would say, well, this also has an arrow pointing down, but you know how we read words from left to right? You also read lines from left to right. So if you go from left to right, you would say that this line is pointing up, or this line is going uphill, which means it has a positive slope. This line from left to right is pointing down. So from left to right is pointing down. Any straight line that points down, you would say has a negative slope. And then there's 2 other types of lines. Either it goes up or it goes down, or you have a horizontal or vertical line. So those are the 4 things that can happen. You can have a positive slope, a negative slope, a horizontal line, and horizontal lines have a slope of 0, or a vertical line, and the slope of all vertical lines is undefined, okay? Now, if you have an equation where you see the y and the x, the number that's being multiplied by x is the slope. So we would say the slope of this line is positive 2. Since the slope is positive, that's why our line points up and to the right. This slope being multiplied by x is negative 3. So that's why our line is going down and to the right. And then when you have horizontal and vertical lines, that means that you only have one of the 2 variables. So these 2 lines have x and y. Horizontal lines only has a y in the equation, no x at all. And vertical lines only have an x in an equation. That's it. So either you have both variables and your line goes up or down, or if you have a y, it makes a horizontal line. If you only have an x in your equation, you end up with a vertical line. All right, so let's identify the slopes from these graphs. So the question is the slope positive, negative, 0, or undefined? So let's look at letter A. So that's a vertical line, and we just said that vertical lines have undefined slopes. So the slope of this vertical line is undefined. All right, let's go down here to letter B. Looking from left to right, this line is pointing down. So we would say that this has a negative slope. Letter C, that's a horizontal line, and we just said that horizontal lines have a slope of 0. And then letter D, going from left to right, this line is going up and to the right, so we have a positive slope. Okay, so we didn't identify like the number for the slope, but we identified whether it was negative, positive, 0, or undefined. So hopefully that makes sense to you. All right, now we can find the actual slope, which would be a number. So either you have a positive number if you have a positive slope, or you have a negative number if you have a negative slope. Now you can also call slope rate of change. So slope has many different names. When it's proportional, like when you learned in 7th grade, you learned the term, the constant of proportionality. So that's one other interchangeable term for the slope. Also, rate of change or constant rate of change. Those are all different terms for the word slope. All right, so what you do when you have a graphed line and you want to find the slope, then slope is written in the form rise over run. Rise over run. How tall it is on top, and how far you go right or left is the bottom number. So all I have to do is take any of these points and I am going to make a right triangle. I can do it above the line or below the line, it doesn't matter. But my top line has to be how far up my 2 dots are. So how many spaces from here to here? 1, right? If I do it here, it doesn't matter. It's also 1. My rise is 1. And now my run is how far to the left or right. So how far to the right? 1. How far to the left? It doesn't matter. 1. So I would say my slope is positive 1. 1 divided by 1 is 1. My line is going up and to the right. So the slope of this line is 1. All right. Let's look at this one right here. So we have a coordinate here. This is not on a corner of a box, correct? So I could look at this one and go, okay, well, that's an exact coordinate right here. So I'm going to make my triangle. All right, the rise is how tall it is. So it's 1, 2 spaces. The run is 1, 2, 3. So I'm going to put rise over run. And then I pause and look at it and think, is this going up and to the right or down and to the right? So this is going up and to the right. It's a positive 2 over 3. The slope is positive 2 over 3. All right, what about this one? Well, I have several different dots, so I can make a right triangle anywhere really, it doesn't matter. But now when you think about the rise, this doesn't represent 2 spaces, does it? Look over here at your y-axis. This represents 75 and this represents 150. So the rise is 150 and the hours are counted by 1, so 1, 2. So the rise is 150 and the run is 2, which means the slope is positive 175. Okay, got to pay attention to your y-axis. These are all increasing by 1. These are increasing by 1. The rest of them are, but this one isn't. It's increasing by 75. All right, so I'm going to make a right triangle here. So what is my rise? 1, 2. My run is 1. So it'd be 2 over 1. And do I have a positive slope going up or a negative slope going down? It's a negative slope. So I'm going to write negative 2 over 1, which simplifies to negative 2. And then here I have an exact coordinate right there. I'm not going to use this. Yeah, this is 1 as well. Yep. All right, so I'm going to do my rise over run. And once again, I have 2 over 1. These are exactly the same. I didn't realize that. So the slope of this line is also negative 2. Okay. So that's how you get slope from a graph. All right, what about from a table? Now, last week, I actually took these 3 problems from last week's lesson I sent you. So one thing we can always do is find the slope from a table by using this formula right here. If we have any 2 coordinates, we can figure out what the slope is. So let's name this x1 and let's name this x2. And this will be y1 and y2. We can do that on all of these, x1, x2, y1, y2. And it doesn't matter. We could pick any 2 coordinates. It doesn't matter. This could be x1, and this could be x2, and this could be y1 and y2. All right, let's pick this for x1 and this for x2. and this for y1 and y2. So you can pick whatever you want for your x's, 1 and 2, but your y's have to match it. So y1 has to be the same line as x1 and so on for x2 and y2. All right, and so here we have two coordinates. So if I wrote these on my, if I wrote these on my graph, I would say 20, 120, and then 50 and 300. So I'm going to do x1, x2, y1, y2. All right, well, it doesn't matter. Like I said, you can pick anything over here. So let's do x1, we'll do x2 just to mix it up, y1, y2. All right, so we are going to find slope, and in math, slope is always given by a m, letter M. I don't know why it is an M, but it is, and so that's what we use. So we're just going to plug these right into this formula. So let's start with the first one over here. Let me change colors. So let's say I'm going to use my y2 minus y1. So y2 is 7 minus y1 is 6. Over x2, which is 2, over x1, which is 0. So 7 minus 6 is 1, and 2 minus 0 is 2. So I just found the slope is 1 over 2. The slope is 1 over 2. All right. What about this one? And you could also call that the rate of change. The rate of change is 1/2 or 0.5. All right, let's start with our formula right here. We start with y2, always the change in y over the change in x. So we're going to do 135 minus y1 over 3x2 minus x1. So 135 minus 90 is what, 45? Yes, over 1. So our constant rate of change or slope or rate of change is 45. That's what this one is. All right, let's do this one. y2 is 0 minus y1 is -8. Don't drop a negative sign. y2 minus y1. And then we're going to do x2 minus x1. So then don't leave that minus a negative. We're going to do bam, bam. So 0 plus 8 is 8. 1 minus 0 is 1. So our rate of change or our slope is positive 8. Positive 8. All right, now we're doing this table. We're going to do y2, which is 11, minus y1 over x2, which is 4, over x1. So 11 minus 5 is 6, over 4 minus 2 is 2. So what's 6 divided by 2? It's positive 3. Now, you don't always get positive slopes, but in this situation, so far, that's all we have is positive slopes. All right, so let's do x2 minus x1. Am I saying x? I mean y. y2 minus y1 over x2 minus x1. So 300 minus 120 is 180. And then 50 minus 20 is 30. So what's 180 divided by 30? It would be 60. Our constant rate of change is 60. And then the last one, do y2, 146, minus y1, which is 56, over 15 minus 6. So I don't know. My brain is tired. Let's do 146. 146 minus 56 is 90, and 90 over 9, right? So the constant rate of change is 10. 10, okay? All righty. So that's that. I was just double checking that last answer. All right, so that was from finding slope from a table. Now we're gonna find slope from an equation. So this is the easiest thing to do. The slope is the number multiplied by x. That's it. It doesn't include x, but x is how you find the slope. It's the number being multiplied by x. So in this first equation on the top, what is our slope? The number being multiplied by x is 2. Our slope is 2. On the second one, what is our slope? Positive 1/4. On the third one, what is our slope? It's not 6. Why? Because 6 is not being multiplied by x, so it's 4. The slope is 4. On this one, what is our slope? It's not 1/3, but it's negative 1/3, right? Negative 1/3 is our slope. You cannot ignore the sign in front of it. There's our slope. Now, remember earlier when I talked about vertical and horizontal lines on the first or second slide, right? I told you that if you have an X only, that means you have a vertical line. And what I tell you about vertical lines, what's the slope? The slope is undefined. And then I told you if you have a horizontal line, that means there's only a y in the equation. And the slope of horizontal lines, oh my goodness. The slope of horizontal lines, do you remember, is 0. Okay, I'm going to give you an acronym to help you remember vertical and horizontal lines in just a few minutes. All right, you do have a multiple choice question on one of your first lessons. So you need to make sure you know that how do you describe slope? Slope you can describe as either, or all of these are correct, a constant rate of change. Also, it measures change, constant rate of change, and slope can describe a proportional relationship. When you have a proportional relationship, the slope is the unit rate. All right, so all of these, well, no, it's not true. I'm going to tell you real quick about proportional relationships. I'm going to tell you how to identify a proportional relationship. So 2 criteria. The first one, all proportional relationships must be linear. That means they must make a straight line. And the second thing is true about proportional relationships is it goes through 0, 0. It starts at the origin, okay? If you have a straight line that does not go through 0, 0 or touch 0, 0, it is not proportional. So of these 5 graphs, there is one that is not proportional. Can you find it? Do you see which one does not go through 0, 0? It's this one. This is not proportional because it does not go through 0, 0. The rest of them all go through 0, 0. Right there is the origin, the origin, the origin, and the origin, right? So these are all straight and they go through 0, 0, or they touch 0, 0, which means they're all proportional but this one. Now, like I said, look, I put slops. Pretend that says slope. So when you have a proportional relationship, like I said earlier, the slope is also considered the unit rate. So how much for 1? How much for 1? And one way you can always figure out the unit rate is you always divide y by x. You take any point and you divide y by x. This is for unit rate. So I hope you guys print off my notes or print off these problems. Not only, you're not just listening and watching me, but you are taking notes yourself. You're practicing along with me. You're pausing the video. You're trying some by yourself, and then you're going to go and check and see if you're right. So if you're not doing all that, that means you could do more to make sure you understand these lessons better. Okay. So it takes a lot of discipline to be a virtual student. Okay, so make sure you're doing it the right way. All right, so since we just identified 4 proportional relationships, I want to know what the unit rate is. Well, you're going to divide your y, which is always this axis, by your x. So what does this y represent? 6 fifths. So you could leave it like that. You could say 1 1/5, or you could say 1.2. All right. Is that right? Yes, 6/5. All right, what about this one? What about this one? Well, what is my y? My y is 15. So what is my x? My x is 10. So my unit rate is 1.5 or 3/2. You could say 3/2. So that means how much for one? So in 1 hour, we would travel to 1.2 miles. Which doesn't look right because that's going to be a 2 right here. 5 miles, we would go 6. 10 miles, we'd go 12. 10 times 1.2 is 12, 15, and 18. 15 times 1.2 is more than 18. Why is this wrong? All right, what about this one? This would be 10 divided by 2. 10 divided by 2 would be 5, which looks right, because for 1 it'd be 5. Oh, because this isn't 1, you guys. This is 2.5. Oh my gosh, I was so confused. All right, so that makes sense. So 1 would be down here at 1.2. Okay, I was so confused for a minute. I wasn't thinking straight. All right, so what would be my 3 divided, or no, it'd be 2 divided by 3, right? 2 divided by 3, which is 0.66666. And all of them are the same. Now I'm picking the first dot, but you could pick any of them. As long as you divide y by x, you got their unit rate. Even 9 divided by 6, no, it'd be the opposite. 6 divided by 9 is 2/3. So they're all equivalent, okay? So that's how you find the unit rate. You divide the output by the input. All right, what if I didn't necessarily have these charts. Let's say I had a T-chart, right? Or a table. Let's say I had a table. Well, let's just put a couple of points on here. So this coordinate is 210. This coordinate is 630. This coordinate is 945. And how do you find the rate of change? You divide the y by the x. So isn't 10 divided by 2, 5? Isn't 30 divided by 6, 5? And 45 divided by 9 is 5. Well, same thing is true with all of these. If we wrote any of these ordered pair on our T-chart and we divided the y by x, it would tell us our unit rate. Now that's only when it goes through 0, 0. If you have a different y-intercept like this one, when you divide y by x, that's not going to give you the rate of change. Okay. All right, so let's look at this top question up here. It says Sarah buys 3 boxes of chocolates for $3.75. What is the unit rate? It wants us to write an equation. So Sarah would spend $3.75 on 3 boxes of chocolate priced X amount of money each, because we don't know how much they are each until we divide both sides by 3. Or if we made a T-chart and X is the number of boxes and Y is how much money we spent, how do we find the unit rate? We're going to do the same thing. We're dividing Y by X, just like this shows. 375 divided by 3. And if I do that, I find out the unit rate is 1.25. So this is money, which is also considered the slope. If I took this information and I graphed it, I would have a positive slope of 1.25. All right, the next thing says to compare the table and the equation, which has the greater slope. So what is the slope of this equation? So the slope of this equation is 4.5 because it's being multiplied by x. This is also a proportional relationship because it doesn't have a plus or minus number. So that means it's plus 0, which means it goes through the y-intercept, or excuse me, the origin. And then if we do our change, we can either, if we know this is proportional, we could divide y by x. in any of these situations, and we're going to get the same answer. So this is 5, this is 5, this is 5. Or you could think of your y2 minus y1 over x2 minus x1. So 15 minus 10 is 5. 3 minus 2 is 1. And any way I do it, I still get the same slope of 5. So which of these two, this table or this equation, has the greater rate of change, the greater slope? It would be this table, because 5 is greater than 4.5. All right. Now, like I said earlier, one way you can find the rate of change or the slope from a graph is you can make a right triangle. So take any 2 points and make a right triangle. And then we're still going to count rise over run, right? So I have a rise of 1, 2, 3, 4, 5, 6, 7, 8. And here my run is 1, 2, 3, 4, 5, 6. So my rise over run is 8 over 6. All right, let's say that I decided not to use this point. Let's say I wanted to use this point, these 2 points. Well, I could still make a right triangle, and I'm still going to find rise over run. So my rise is 1, 2, 3, 4. And my run is 1, 2, 3. Well, what's true about 8 over 6 and 4 over 3? These are equal, right? Which means that this great big right triangle and this smaller right triangle are similar. So if you have 2 similar triangles, the ratio of the sides are the same, then that's the same slope. So simplified, you would say the slope is positive 4/3. Okie doke. All right, now this is an equation. This is a linear equation. When it's written like this, where the y is by itself, this is called slope-intercept form. And the reason it is because it's the way it's written. That number that's being multiplied by x is the slope. So it's very easy to identify the slope. Now the letter B, that represents the word y-intercept. Now, when you have a graph, almost always, not always, but almost always, your graph that you draw is going to intersect the y-axis. Well, the y-intercept is the number where that line crosses the y-axis. And since it's going to be on the y-axis, that means the x value is always 0. So what is this coordinate right here? This coordinate is 0, 4. The y-intercept is 0, 4. That's where it intersects the y-axis. Well, when you are given this slope-intercept form, it's telling you the slope is the number multiplied by x, and the other number that isn't multiplied by x, called a constant, is the y-intercept. So that's the number where it's going to cross the y-axis. So the slope of this line is 4 because it's being multiplied by x, and the y-intercept is going to cross the y-axis at -7. So the x is going to be 0. Every time you have the y-intercept, x is equal to 0 every time. And the y-intercept is going to be the y value. So the slope of this line is 4, and the y-intercept is 0, -7. All right, I could figure out the slope of this line by making a right triangle. Oh my goodness. Let me make my right triangle. Find my pen, turn my pen off. All right, so if I wanted to make a right triangle, I could, and I would say my rise is 1, my run is 2, and it's negative. So I would write my slope, -1 over 2 times x, because that's the slope. It's always multiplied by x. And then this is a +4. My y-intercept is at 0, +4. That is the equation of this line right here. All right, what is my y-intercept down here? My y-intercept is 0, -1. X is always 0 when you find the y-intercept. It crosses at -1. So 0, -1. And then I could make my right triangle. and I could say my rise is 1, my run is 2. This line is going down and to the right, so my slope is -1/2, and my y-intercept is -1, which makes my equation y equals -1/2 x minus 1. That's the equation of this line down here at the bottom. All right, so let's look at a few questions that you're going to see when you go through these lessons. Number 1, what is the equation in slope-intercept form? Now remember, slope-intercept form is when y is by itself. For a line that passes through 0, 9 and has a slope of -4. Well, this tells us the y-intercept, and the reason I know is because x is equal to 0. Do you see that? When x is equal to 0, the y value is the y-intercept. So what's the equation of the line? My slope is -4. That's what I multiply x by. And since x is 0, +9 is my y-intercept. Look at number 2. What is the equation in slope-intercept form for a line that passes through the origin and has a slope of 2/3? Well, what is the coordinate of the origin? What's the ordered pair? 0, 0. All right, well, x is 0, so the y value is the y-intercept. So the y-intercept is 0. So y equals my slope times x plus my y-intercept. Well, the y-intercept in this situation is 0, but like if we write the number 5, do we write 5 plus 0? No, but it's the same thing, isn't it? Well, we won't ever see someone write plus 0. They'll just drop it, just like we would with any other number, right? So that is the equation of the line that goes through the origin, has a y-intercept that's 0 and a slope of 2/3. All right, which equation best represents the relationship? Well, I gave you these choices because there's a couple of ways you can do this. The first thing you can do is finish the table and find out what y is when x is 0. Why do we care? Because when x is 0, the other number is the y-intercept. So you see how these numbers are, the pattern is, if I'm going from bottom to top, -2, -2, -2, -2, right, to 0. And then what's the pattern here? -1, -1, -1. So if I subtract 1, I would get 2 here, wouldn't I? So if I find out what y is when x is 0, that's the y-intercept. So my y-intercept is +2. Now look at my choices. I can automatically get rid of this, and I can automatically get rid of this because the y-intercept is +2. The other way to find out which is the right answer is I can just take these x values, plug them into both equations and see which one's going to give me my y value, right? So if I put x is 2, does 2 plus 2 equal 3? No, it doesn't. So I know that's not the right answer. So that's one choice I could do. I could take my equations, plug in my x values, and see if I get the y values. Or remember the other way to do it, we do, if this is x1, this can be x2, this is y1 and y2. We can find slope this way. So y2 minus y1 over x2 minus x1. Well, 6 minus 5 is 1, and 8 minus 6 is 2. This tells me my slope is 1/2, and my y-intercept is +2, which means that A is the right answer. So those are all different ways I can figure out which graph goes with, which equation goes with the table. All right, so I told you that we've talked a little bit about vertical and horizontal lines. So this is an acronym that's going to help you remember, hopefully, which one goes with X, which one goes with Y. So when you're taking these notes, I want you to write out VUX HOY. So what does this mean? So V stands for a vertical line. U means undefined, so that's talking about the slope, undefined slope, and the X means there's only an X in the equation, only an X in the equation, right? All right, what does hoi mean? Hoi, the H means I have a horizontal line. Whoops. I have a horizontal line. The O actually represents that the slope is 0, and the Y tells me there's only a Y in the equation. Okay, so if you'll remember the acronym VUX HOI, hopefully when you go, okay, vertical means VUX. That means the slope is undefined and there's only an X in the equation. HOI, horizontal, 0 slope, and only a Y in the equation. So since I have a horizontal line right here, that means my equation only has a Y. Well, what is my Y value? Well, look at the Y axis. This crosses where? Where does this cross? What number is this? All right, let's take several of these coordinates that this line goes through, right? What is this coordinate right here? It'd be -4, -2, -4, -2. What about this point right here? What would this be? -2, -2. What about this right here? What is this coordinate? It's 0, -2. What about this coordinate? It'd be +3, -2. So what do these all have in common? No matter what the X is, Y is equal to -2. That's the equation of this line, because every single point on that line has a -2 in the Y value. All right, so here we have a vertical line, right? So we think of VUX. So if I saw this line and I said, hey guys, what's the slope of this line? Hopefully you would think of VUX, and you know that the answer is undefined. And then we know that there's only an X in the equation. So what does X equal? Well, let's look at some of these coordinates right here. What are all of these coordinates? What is this coordinate down here? It's -4, -4, right? -4, -4. What is this right here? It's -4, 0, -4, 0. What is this coordinate right here? It's -4, 3. And I could keep going, right? But do you see the pattern? This says no matter what Y is equal to, X is equal to -4. That's the equation of the line. So I hope that helped you guys. Like I said, you probably want to go through it twice. You need to go through the lessons in the Florida Virtual. You want to go through the lessons, do every single practice problem. I think there's 1, maybe 2 videos. There's several different practice problems. I want you to write down the problems that they give you and they give you the solution to them. And then go through this video and look at my examples again, because it will help you, I promise. All right, this is a huge part of 8th grade math, just trying to get linear equations. And then soon we're going to start graphing them ourselves, okay? All right, you guys. Well, I will see you later on. I hope everybody has a great week. If you need some help, let me know. But you do your part, okay? You do everything you can to understand it. All right, everybody have a great day. I'll see you.